Hey everyone, welcome to my channel. So in this video I'm going to go through this question, explain this piece of code to see how we are going to solve it. At the same time, I'm going to try to follow the general interview steps while trying to explain this piece of code and the solution. So let's get started. First of all, let's read through this problem to get a good understanding about it. So write an efficient algorithm that searches for a value in the n-by-n matrix. So this matrix has the following property. Integers in each row are sorted from left to right, and the first integer of each row is greater than the last integer of the previous row. So the property of this matrix seems like if we change the last number for the current row with the first number of the next row, then we can potentially just have a 1D array which is sorted from the smallest to the largest. So having said that, it's just a binary search, pretty traditional binary search question. So the difference between the traditional binary search with the situation here is that we have a matrix, which means we are going to turn the index of the 1D array into the corresponding row and column within the matrix. So having said that, we are going to use binary search to solve this problem, and the runtime is going to of course log mn because we have m times n numbers within the matrix. So let's see the constraint. So constraint says the matrix is never going to be empty, and the value is anywhere between minus 10k to 10k for each number within the matrix, and also the target. So for this piece of code, we care about speeding and also correctness and readability. So first of all, we define a helper class, which is going to indicate the row and the column within the matrix. And then we define a helper function to turn the 1D index, the index in the 1D array into the corresponding position in the matrix. So we are going to pass two parameters, the index within the 1D array and the number of the columns. And then we try to write this function search matrix. First of all, we get the row and column number, and we define the left as a 0 and right as row count times column count minus 1, which is something like if we change the matrix into a 1D array, the last number, the index of the last number. So then the rest is pretty traditional binary search writing. So we have the made, and we translate the index into the corresponding position within the matrix. If the made value is equal to target, then we just return true. Otherwise, we are going to change the right or left pointer depending on the relationship between the value in the made index and the target. And finally, if we just jump out this while loop, we are just going to return false. So that's pretty much it for this coding question. If you have any question regarding this solution or regarding this piece of code, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.